Hi, this is Henk Akkermans, and this is Supply Chain Dynamics Chapter 2, Sysdea Gameplay 1, Exponential Growth. For exponential growth, we need one stock and we need a flow, and a connection between the two. So we have a stock which I will call rabbits, rabbit population. The initial size of the population, well, let's call that initial population, will be 1,000. And this is another way of getting that initial value here. I could have typed 1,000 in it, but this way I can manipulate both variables more easily. And I have a flow, growth of the population, births, and I'll connect it not the most decent version. Yeah, there we go. So how fast will those rabbits grow? Well, that will depend on the rabbit birth rate. Rabbit birth rate percentage. And let's make that 5% to start off with. So that's 5% of the rabbit population grows per time period. Rabbit population times rabbit birth percentage. You already see a nice, almost linear growth. We can, of course, make this more visible if we take the, take the birth rate in there. What you do see is a big difference, of course, between the two. You see that initially, over the first 12 time periods, growth almost looks like linear. But that is a function of the time periods. If I make this 50 time periods, you start to see where the exponential growth pattern kicks in, which is a characteristic of exponential growth, which is that in the short run it almost looks linear because the change in growth from one period to another isn't so big. But over long time periods, it's definitely exponential. So especially over long time horizon, it's really tricky to assume linear growth.